Okay, so this is a video answering a question about how do you evaluate a non-traditional op-amp and a square wave input at a certain time. In this case, it's what is V out at 750 milliseconds. Let me start with saying any question with a time stamp on it and a waveform, I do expect you to draw a square wave. And this is a 1 Hertz square wave, so it goes to 1 second, 2 seconds. The period is t is 1 second, which is 1 over the frequency. At 750 milliseconds, that means it's here more or less. It's halfway through the second part of the period, and therefore this V, and it's 0.5 volts peak, so it's minus 0.5 here. So the voltage of the square wave at 750 milliseconds is minus half a volt. So I can think of this in my head that there's going to be minus 0.5 volts here when I am evaluating the output of that op amp. So that's the first thing. Second is I need to note the rails. Here the rails are minus 5 and 10. So the output, I already know it needs to be between minus 5 and 10. But I want to calculate that, and I'm going to use superposition because there are two power supplies here. And first I'm going to use only the 0.5 volt, the minus 0.5 volts. And here's how the circuit looks like. If I'm zeroing the 2 volts, that means turning it off, I'm shorting that to ground. Now there are two resistors here to ground, the 2K and the 5K. But the 5K and the 15K are still there. I mean, all the resistors are still there. And here's a minus 0.5 volts. And as you see here, both of them are grounded, and the input current on the op amp is 0. Actually, I'm always going to use these two rules of the op amp, which are the current on the negative terminal is the same as the positive, and it's 0. And there is a mirroring of voltages from the plus to the minus. So that mirroring means that this is going to be 0 volts here. There's no power supply. The current is 0, so really there's 0 volts here. And this node A here will have 0. Actually, because this is 0, this turns into a non-inverting amplifier. Oops, this turns into an inverting amplifier, because my signal is on the negative input, and this gets multiplied by minus 5. So really this V2 here, I'm not sure why I'm calling V2, will be minus 0.5 times minus 15K divided by 5K, which is minus 3. So minus times minus, that means it's 1.5 volts, the output, because of the 0.5 volts, the minus 0.5 input. And now only the 2 volts. Now I'm going to zero that guy, the minus half. And I'm going to leave everything else in. 15K, 5K. This guy goes to 0. And I'm going to leave the 2 volts in. $5K and the 2K. So now these 2 volts, what happens is this, oopsie, plus and minus, and I'm going to call this V3. This here is a non-inverting amplifier, except that the 2 volts, let me draw with another color here. The 2 volts are going through a voltage division. Here, it puts a voltage here and a voltage here. The reason this is a voltage divider is that there is no current going into here. So there's 0 current into the op amp. So it's really the 2 volts being divided into the 2 and the 5. So a voltage divider like that, with the plus on the top, 2 volts, means the voltage here, and this is ground, this voltage here is 5/7 of the 2 volts, which is 10 divided by 7, which is, if you don't have a calculator, it's going to be 1, and then 3 divided by 7 is almost 5, so I'm going to call this 1.4 volts. So really this voltage here, the input is 1.4 volts. But as a non-inverting amplifier, go back to blue, V3 will be this 1.4 volts times 1 plus the ratio of these two, which is 15 over 5, 15K over 5K, which is 3. So this is 4. So V3 will be 4 times 1.4. Do I know the answer to that question? 5.6 volts. So finally, when you go back from the superposition, you need to add these two. So I'm going to add V out will be 5.6 plus 1.5. And remember, it's just approximately. V out is approximately 7.1. I hope this helps, but if you would like me to answer any other questions, please let me know. I'm assuming we don't have a calculator. I'm also assuming we're going to do a lot of this. For example, if there are 2 power supplies, doing superposition from my perspective is simple, but you could have just put the 1.4 volts here and done KCL on it. So that's another way of solving the circuit without superposition.